Logistic regression is today's topic of discussion. It is used for binary classification prediction problems. Binary classification can be like male or female, yes or no, disease is there or not, like this. Logistic regression uses a logistic function. This is also called as a sigmoid function. So this sigmoid function will generate an S-shaped curve. So it will be taking a real valued number and it will be mapping if you plot it, it will be mapping in the range 0 to 1. So this formula 1 upon 1 plus e to the power of minus value, here e indicates the base of the natural algorithm, Euler's number or exponential function. So you can see here there is a logistic function and plotted for the range of values -5 to +5, and this is a S-shaped curve generated in the plot. And here we use a formula called as y is equal to e to the power of b0 plus b1x divided by 1 plus e to the power of b0 plus b1x. And we know that if I want to understand the difference between a linear regression and a logistic regression, the logistic regression will be generating an output in the form of a binary value 0 or 1, yes or no kind of thing. Here in this formula also, y is the output variable, which is a predicted variable. B0 is the bias or intercept. B1 is the coefficient for the single input value x. Now this B coefficient has to be learned from the training data. So what basically logistic regression algorithm does? Logistic regression algorithm will be predicting probabilities in some range, let us say 0 to 1, and these will be plotted, and then they will be classified as binary classification. Let us say we want to model a people's sex as male or female depending on their heights. This can be represented as P of sex is equal to male bar height. This can also be represented as P of x is equal to P of y is equal to 1x. Logistic regression, like linear regression, is a linear method. These outputs predictions of logistic regression are transformed into binary classifiers using a logistic function. Now, we have seen this formula y is equal to e to the power of b0 plus b1x divided by 1 plus e to the power of b0 plus b1x. That same can be represented as P of x is equal to e to the power of b0 plus b1x divided by 1 plus e to the power of b0 plus b1x. This, when we convert it into a logarithmic function, it will be represented as logarithm of p of x upon 1 minus p of x, which is equal to b0 plus b1x. Here, the ratio on the left side is called as the default class. We also know that when odds are calculated, they are calculated as the ratio of probability of the event divided by the probability of not the event. So you can see the numerator as probability of the event and the denominator as probability of not the event. So logarithm of odds is equal to b0 plus b1x, that representation is forms. So these are called as log odds, or these are called as probits, or these are called as logit link functions. And we can simplify it by writing this representation. Odds is equal to e to the power of b0 plus b1x. Now, next part comes the learning the logistic regression model. What we have to do is the coefficients of the logistic regression algorithm need to be estimated. This estimation is done with the help of maximum likelihood estimation algorithm. What will be the best estimation if the values are close to 1, which is the default class as a male, or close to 0, which is a opposite class in the binary class? Now, how do I do predictions with logistic regression? Let us take the same problem as I want to predict whether the person is a male or a female depending on his height. And let us say the height of the person is 150 centimeters. And the coefficients derived are B0 is equal to -100, B1 is equal to 0.6. So, if you put these values in this formula, the resultant you'll be getting as 0.000045397867. And we know that it is nearing 0. So, this can be represented as prediction is equal to 0 if P of male is less than 0.5. Prediction is equal to 1 if P of male is greater than equal to 0.5. So here my prediction comes to be 0. Am I right? Now, there are few assumptions which we need to make while preparing the data for logistic regression. One is there is a binary output variable. It's a binary classification problem. So we need to remove the noise to avoid the errors, remove the outliers. The distribution is Gaussian and the relationship is linear between the input and the output. Correlated inputs need to be removed to avoid overfitting, and there is a chance of failure to convergence if there are many correlated inputs in your data, or if the data is very sparse. What is the meaning of sparse? Lots of zero in our input data. Let us take one example for this logistic regression thing. We have here our data set here, and we have our output variable as y. This is our output variable y, and you can see the output variable has two binary classified outputs, either 0 or 1, right? And these are our inputs, and you know two input variables are there, x1 and x2, which are real valued random numbers which are drawn from a Gaussian distribution. So this, if we plot, the graph will look like this. Now, what we'll be taking is our default class we are taking as class 0. And the default class 0 will come when the probability is greater than 0.5. We know the formula that y is equal to b0 plus b1 into x1 plus b2 into x2. We also know this probability of class 0 is equal to 1 upon 1 plus e to the power of minus output. So which is equal to 1 upon 1 plus exponential of minus output. We need to first calculate the predictions. For that, we are making the initial assumption as all the coefficient values to be 0.0. That is, b0 is 0.0, b1 is 0.0, b2 is 0.0. And then we are taking the first instance of x1 and x2, which are 2.78 and 2.55. And then we are putting those values in this formula, 1 upon 1 plus e to the power of minus b0 plus b1 into x1 plus b2 into x2, so which is coming to be 0.5. After this, we need to calculate the new coefficients, okay, because initially we have assumed the values of coefficient to be 0.0. Now, to calculate the new coefficients, we'll be using a simple updated equation called as b is equal to b plus alpha into y minus prediction into 1 minus prediction into x, where alpha is a learning rate. Okay, and this alpha controls how much the coefficient changes or learns each time it is updated. So the good values for this will be between the range of 0.1 to 0.3, and in our example we are taking the value of 0.3. When you are putting that value of 0.3 and we are putting the prediction value as 0.5 in this formula, then we are getting the values of the coefficient of b0, b1, b2 to be these three values. So once we calculate the new coefficient values, we'll be iterating the process, repeating the process. Okay, each iteration on the training data set is called as an epoch. Okay, so and we know the stochastic gradient descent procedure is an optimization algorithm. Okay, and we can decide a fixed number of epochs, and at the end of every epoch at the end of every iteration we can calculate the error values. Okay, as it is a classification problem, it would be good if we get an idea of how accurate the model is at each iteration. That accuracy can be calculated or plotted like this. And in this example, we are saying 100% accuracy. Now coming to making the predictions. So till this time, what we have done, we have trained the model. We have trained the model, right? Now we can predict and we decide the number of epochs to be 10, and these are my x1 and x2 variable values, and these are my predictions. So after getting the predictions, I know that if the value is less than 0.5, then the classifier will be 0. If it is greater than 0.5, the classifier will be 1. So like this, we'll be getting the predictions as this. Coming to calculating the accuracy, the formula for calculating the accuracy is number of correct predictions divided by total number of predictions multiplied by 100. I know that all the predictions are correct, and so that the accuracy I am getting is 100%. So this in a nutshell is logistic regression. Logistic regression is a linear problem. It's a classification problem. So the predictions are done using logistic regression for binary classification problems. That's it. Thank you.